Okay, so time to get. Keep doing this. So, how's everyone? Ready for Thanksgiving? Sounds like it. Sounds like some people couldn't wait. They're like, I have to get turkey right away. Cool. So, I have your exams in my office. If you haven't taken a look at them, you can stop by right after class, for instance, or office hours tomorrow. Or if you want to email me about grades. Thank you for sending me the scripts. In general, they seem pretty good. Some of them could use a little bit, like a sprinkle more ambition about what to cover. And I'll respond to those when I get hands-on keyboard, hopefully later today. As for the presentations themselves, so they need to be recorded, need to be uploaded and so forth. So if you have, if you send me like a link to an MP4 file or something, I can upload it for you, or you can put it on YouTube yourself and send me the link. But yeah, ultimately it's going to need to be an uploaded 10 to 12 minute presentation. And then we're going to show up in class, I think next week. Didn't we get next week on that? And watch them together. Popcorn. And for that, I need you guys to be present so we can ask you questions about your presentation. Does that make sense? Does somebody want to use the green screen in my office? Oh, okay. I'll just use it then. Okay, that's fine. How was the web lab? What did you guys think? Yeah. Weird.
Just compared to all the things that we've done earlier, this is a departure.
It's a departure. In what way? Explain.
I guess it's more of just taking a different approach.
Mm-hmm.
Instead of just like, okay, I had this program sitting in front of me.
Yeah.
How do I stop this? It's now about getting in between things or hearing.
The mindset is a little bit different.
Yeah, it is.
Yeah. But in a fun way, right? Like it's just a. Never mind. Yeah, I want to put words in your mouth. Some people think, yeah.
Yeah, actually,
You enjoyed it, yeah? Yeah. If you had experience with web stuff, it tends to be that people are like, oh, okay. Smorgasbord of all sorts of fun stuff that can go wrong. Okay? Yeah?
Yeah, I felt a lot more creative than some of the other labs, and it's definitely really informative.
Good. So general, it was okay? Was it, what do you guys think about the SQL injection version there, of the separate website? Shake your hand. Why do you shake your hand?
For some reason, you can't, once you do an exploit, for some reason, like Chrome browsing, when you try to do it again to see what was going on, you can't do it again. But if you go to another, I use Safari, it did it. I don't know why.
Weird. Some cache thing? Was that the only thing that this credited on the whole enterprise? Or was the lab itself reasonable? The labs and SQL injection? I'm kind of soliciting feedback because we're currently making that. We're trying to make it better. So all feedback would be welcome. I may send them a little survey to this. Okay. Please. People are like callously looking away. Okay, fine. Any other feedback on the problems and projects so far? Yes.
I think the slides that we posted this week wasn't very helpful.
Oh, the OWASP?
Yeah.
The ones I put on that. Okay, that's good to know. So.
At all.
They were opposite of helpful. Okay, that's also good to know. So what would have been better?
Well, it seems like you had like a good skeleton, and I'm sure if someone had like presented a lecture on it, they could have, everything they would have said probably would have been helpful, but the slides themselves without that lecture.
Works that far. Okay. What about in the SQL injection where we added text in between? Was that helpful? I guess we did cover SQL injection in class, but like what we're trying to do is to have text in between all the different exercises. So like what you were using was like an old version of like a prototype we were creating, and we're creating like the new version, which is starting with the SQL injection stuff, where we have like kind of information in between. Was that helpful information for anyone? No. Okay. good feedback, it's good feedback.
Wait, well, is your website under development, SQL one?
Yes, so that's, we're
Oh.
currently developing it.
Okay.
Yeah, I mean, there's
Yeah.
really excited kids once a week, they're like, oh, what is that name? So I'll crush their spirits, don't worry.
No, it was nice. I was just wondering why it was like half the links weren't working, so.
Half the links aren't working.
Not like links, but like, when like, so when you saw something and it says, okay, go to next, like, doesn't actually go to next, it just like clicks and
Oh,
that's
yeah,
how
they were
it's, like,
worried about
things
that.
like that.
Yeah, uh-huh.
I was wondering why.
Yeah,
But
that's
that
fine.
explains it.
Yeah. It's very heavily under construction. But thank you for trialing that for me. You had more points? Or-
Oh, no,
Okay, so I mean, this is very useful actually. One of the things that we have noticed is that there really isn't a good OWASP top 10 reference on the internet, right? It's hard to find good information on it. The website is kind of like all over the place. There aren't really any videos, so we're trying to make that material. So that's part of the exercise is to try to scout the internet and learn this stuff. And I know it can be a little bit frustrating to be like, nobody talks about this stuff. What is this? Right? So we'll try to provide that in the future.
I'm curious, where did people find both from?
Oh,
For filter file upload,
sorry?
like, how did they like figure that out?
They went to Piazza, and read one of my posts.
Yeah, but like, other than that,
Oh, how do
if there
people figure?
wasn't there, like, how do
It's
you-
just one of these things like GDP, like
No?
it's just
Okay.
like, if you're in the web exploitation world, Workers kind of synonymous with your main tool.
That made life very easy, so I was
Oh,
wondering
yeah.
why.
Yeah, well, necessity is the mother of invention, right? So people used to just modify their browser request just in the console and send that in. Got a little tedious, so this is going to look GUI for that. It's nice, yeah. And then SSL makes it really hard to do anything from the console, so that's why you also need to use the browser. Fun. Yeah.
You need to have like all subparts for one particular topic to get
So each of them counts as a separate one. So the 10 list there
Yeah.
is just like a categorization of what they fit under in OS top 10. There, like for your grade, there's like 20-something labs, and each lab counts equally. So if there's 5 subparts, you get 5 points, right? So you add that all up, and then I like multiply it by like, so you get like 11 and so on. More questions? No. Yes. Okay. So we're also kind of running out of class material here. So we're going to talk about secure design today, and then we'll have our presentations from you guys. Should be fun. And then hopefully we'll have somebody, a real hacker / director of security at Duo, hopefully talk to us on December 5th. I'm just trying to get the confirmed. So that should be that's somebody who is in the trenches, who is hiring, who has been in the underground, done weird stuff. He's one of my co-founders of Syndis. So he knows the industry extremely well. So if you have any questions about how things work, how the underground works, how security is done at big companies, so forth. He used to be director of security at Etsy, and so forth. Then he might be the right candidate. I'm hoping he can confirm to meet with us, but that'll be like a Skype conversation. So prepare some questions if you have any. Some fun? No? No, terrible. Okay, so let's talk a little bit about security design. And I've been putting this lecture off a little bit because I wanted to kind of run into some of these ideas that we're going to be talking about today, because they can be so dry, right? If you think about it, security is really hard to do, because what we've been doing so far in the course is to break stuff, right? I mean, this is like this is kind of what we've been doing. It's been really fun, right? No? It's supposed to be really fun. We run exploits and we feel powerful and so forth, right? And then we have to kind of sometimes like take on this guy, right? Like who makes all these blocks in Mario Bros? There's some guy whose job it is to make that stuff and trying to make it as robust as possible. All possible attacks and so forth. Must be a terrible job, right? Well, that's kind of what we need to be doing when we're working at our companies, right? We have to anticipate every possible way somebody might try to thwart our progress, try to break our design. And here's the thing, is that like, we may do that really well to begin with, have a really good design and so forth, and then all of those assumptions we made are like obsolete 2 years later, right? It's a process. You can't just like make something and say that it's secure, because then all of a sudden later people discover like, oh, cross-site scripting, whatever. And then you have to revisit it and so forth. It's tedious process, and there's rapid progress in the underground, as we've seen. So coming up with defenses is a, here we go again. So what I wanted to talk about today is a bunch of little points that are kind of little, not anecdotes, but lessons that have been learned through excruciating pain by some people. So they've taken their blood and like poured it into this little synthesis for you to ignore in today's lecture, right? Or you can pay attention to them and appreciate them, and then later in life when you'll encounter them again, you'll savor them and come back to this presentation and be like, what was this about like security design? Now that I'm a manager at this evil corporation or whatever that I found myself doing and I need to make secure software, what were these things that we talked about in class that was just kind of boring? Those are probably the most important lecture. So let's talk about that. First off, something we haven't talked about is value in security, right? So we can always try to imagine that we have fully secure programs. We can spend inordinate amount of effort to try to make something absolutely impenetrable, right? Our software is just amazing. It'll take years to do it, and a lot of effort and so forth, but yeah, it's going to be really safe. Doesn't sound like a very practical thing to do, right? If you think about it in just a real-world analogy, like, are you really going to make like a nuclear safe bunker where nobody goes in and out and there's retina scanners for the bathroom and like, do you really do that? Just say no. Okay. So really, what this is about is that, and this is something you'll find also in argumentation about security, is that somebody will say like, oh no, you could use this and it's more safe. Oh, it's not fully safe. There was somebody who found a flaw, and therefore it's not safe, and therefore I'm not going to use it. Or it's impossible to get perfect security. I'm not going to try. Like you can get this nihilistic arguments with security. Really what all this discussion should be about is that there's some cost, and cost here being your time or your money or both, towards trying to have some level of defense, something to like make sure people can't break it. And there's going to be some cost that the attacker is willing to invest. So when you are in an organization, you're trying to think about security, or you're thinking about your own computer and you're trying to protect it from your ex or whatever, how much can the attacker, how much are they willing to spend to compromise the security? Like if you run a comic book store, probably they'll have a lot of time, but not a lot of money, right? If you are a bank, your attackers are probably willing to spend a lot of time trying to overcome security. You need to have some notion of what the threat is. What is it that you really control? Why would somebody try to attack you? What are they trying to get out of it? Is it for industrial espionage? Is it for revenge? Is it for stealing your money? So how much money are they willing to spend? And then, how much is that defense then worth to you? So there's some inherent value in this defense. You need to factor it into the landscape of your solution, of your system that you created. How much does this defense really do? Is it attacking an important part of your problem? Like for instance, you have an organization and like you never close your windows, but you have a retina scanner for that bathroom, right? Is that really where your money should be spent? Does it really enhance the overall security profile of the thing? And then, how much is bypassing that defense worth to the attacker? Do they need to bypass it? Or can they get most of what they need without it? So think about kind of where you're investing your time and your money so that you're keeping up at least with the attacker. But security is kind of like this weird curve. Like it's a curve where you like can spend more and more effort here on the x-axis to get better and better security on the y-axis, and it's never perfect. And then over time, like wherever you work, can kind of fade away unless you keep it up. It's not something you just do. Prof. Let's talk a little bit about defects of software, since most of what we talked about in this course relates to software. We talked about side panel attacks, and we talked about hardware a little bit. Now lockpicking, how wasn't the lockpicking lecture? It's good? It's fun? Yeah. Get permission. You know you can buy these things on Amazon, but get permission. So we can have defects in software looming there for years. This has happened a lot, like the Zealot library you're bringing up. Or some bugs in the Windows kernel that's been recovered 19 years later. 19 years, right? That's when you have closed source software and nobody gets to look at the source code. It's easy to have those things happen. But it happens in open source software as well. It's just maybe difficult routines, like compression is kind of a topic that you need to have a pretty good degree to understand what's going on. Openness is something. Now, there are really two different types of defects I want to talk about. And we've talked a lot about this first, bugs, right? You make a mistake when you're running through it. And yeah, you can have overruns and you can have exploits against that. But there's a different thing called flaws. And this is kind of what is more prevalent today when people are trying to exploit software, is that they're looking for design flaws. So just to illustrate, this is a bug. It's just something that happened, it went wrong, it was unintended by the programmer, it's just in a spur of the moment slip and so forth. This is a flaw, right? The design is such that it doesn't do what you kind of intended for this thing to do, right? It was some conceptual error that took place, and even though all your preconditions are true, even though all your documentation is supposed, and even if it survives scrutiny for many people, there may just be something that you're just missing, you didn't factor in, right? Yeah, that would be the year one, right? So, one natural question is then, well, so can we then design things better so that we have fewer flaws or fewer bugs? Can we reduce software defects by simply having a better process? Because think about how process works at companies. Maybe you guys don't have a lot of experience working at this company, but there's a lot of, like, you sit down and then you're like, oh, we need all these features and we need to ship by like last quarter, and like you get this inundating pressure on doing stuff. And none of that is usually pressure on you making safe or secure software, because how are you going to measure that in money? We talked about this in the first class, right? It doesn't yield any bottom line right away. It's like insurance, right? Yeah, you need it at some point, and when you need it, you really need it. But for the most part, it's kind of like, yeah, it's something in the future. And the timelines in which the industry is operating doesn't really allow for that. So therefore, security tends to be an afterthought, which is terrible, because you really need to have security design from the get-go, which is an active investment in your product, right? It means that you're not going to have some other features because you spent that time making safer code. Now, unfortunately, even taking, say, making a language be safer. So there's been a lot of work on, like, we've been talking about C. C is an ancient language. C is just that wrapper around assembly, effectively, right? We notice how easily we move between C and assembly. Now, of course, there's been a lot of progress in the programming languages literature making things like Python and Java and Haskell and whatnot, right? It turns out, and this is a study by Google, there's the same number of bugs per line of code for type-safe languages like Java and some others where, like, you say exactly that this is a character, this is an int, and so forth. And type-unsafe programs like C and Python and some others, right? It's just different kinds of bugs. So in the old world, like C, the types of bugs that we've been talking about here are memory bugs. Like you messed up your memory allocation, your buffers, and so forth. You're doing it all the time. Whereas like in the new world, it's API stuff. You get lost in your API, so you didn't quite understand what you needed to provide for that API, or it changed at some point and you didn't update it, or you have some extra methods in your API call that can do stuff you shouldn't be able to access, or something was public when it should have been private, or so forth. Right? Those types of weirdnesses. But it is still an important part of solutions to have better design. So let's talk about design. And please interrupt me with questions so that at least you wake up your compatriots. Okay? Any questions so far? All right. So I'm going to talk through a bunch of different principles. One of them is misplaced trust. When you're designing a program, when everybody was happy and Ymir was small and everything was great, it was easy to trust just about anything, right? We've seen the artifacts of that, like DNS, and I mean they're this kind of like children of their time, and things were just harmonic, right? It was harmony. So suppose you're designing an application today. you will have to make a decision at some point about how much stuff you want to keep at your company, like it's like effectively the back end of the service, or in your database and so forth, and what's happening with the client, right? Imagine you're making a game, for instance. Suppose you're making your own Mario Bros. 5. I don't know what did you make, right? Where does all the logic live? It's a multiplayer game. Of course, Mario Bros. Is multiplayer, right? There's going to be some stuff here at the client just to render graphics and to check stuff. And there's going to be something here in the back end that's talking to other players and so forth, keeping state. What can you trust in this world here? Traditionally, when people were making games, they trusted that there was this binary that they would give to a person to run on the computer, and that binary shouldn't be tinkered with, right? And so you know what's in that binary, you give it to the user, and you just trust that they're using that binary. And then, of course, what do people do? Yes. 13-year-olds want to get ahead in that game. Yeah, they start tinkering with it, right? You should assume that anything here on the client side is fully compromised. That people read through it, they change anything, they modify whatever. You should assume that this is the least trustworthy thing in the world. This here is North Korea. Anything here in the north, right? So, and this is a lesson that needs to come up over and over again. It's probably to trust the user to be trustworthy. Because, yeah, I mean, most of the times they're fine, but when they're not, you're in trouble. So you need to be able to account for it. You need to expect the worst. So gamers, they're going to monitor clients to cheat, right? Get more money, or aim better in Quake or whatever. Your media players with your DVD stuff that you spend all this time trying to come up with, yeah, they're going to get cracked, right? And if there's like a secret key in here for all DVD decryption, yeah, it's going to get leaked. It's just the reality of it. Web browsers, they're going to get compromised. Somebody's going to be a man in the browser, like having one of your tabs and being able to see stuff. Your users are going to be running burp and changing some of the stuff going back and forth. So if you're relying on some state at the client side, you're in trouble. Somebody will modify that state and see that, like, oh, cool, the balance of my account is here in a cookie. Right? Why is it there? Right? It should be here. Or validate it every time it goes back here, right? Mobile apps, they're going to get reverse engineered. In fact, it's really easy to. On your Android phone, you can just take your Java APK file, and you can see it's manifested with all the stuff inside it, and then you can decompile the Dalvik Java code. Very easy. Sure, and then you can obfuscate and so forth. But ultimately, people are going to figure out what's happening to the application. So assume it's been breached. So assume that all data sent by clients is compromised unless it's been proven not to be. Now, what techniques might you have for that? What do you need to know? Suppose you're making that game, and you have all this intellectual property in your client, right? You're trying to make a really nice 3D engine. Like, what do you do? How do you try to protect all that stuff? Yeah, that's kind of what this is kind of the answer that you get when you meet these people. What can we do, right? But you have to try. And what they try is that they can try to, obfuscate things, like active obfuscate, or have anti-debugging techniques, or they can try to have part of the stuff run from the cloud, and you just get the screenshot back of things, or periodically reshuffle, encrypt it only for this client, so at least you'll be able to pinpoint who leaked what. Things like that. Right? You can do this, but you should assume that it's only going to delay what's happening, right? Binary protection can only delay the leaking of sensitive mechanisms, by which time maybe you've recouped your expenses through legal means, right? So ensure that your system works even when some clients have been compromised. And this is true, even imagine you're making Skype. Right? How does Skype work? Or did it used to work? Is that you have this client running in the background of everybody's computer, and then it relays calls between other people that can't connect because of firewall reasons. You're a relay. could potentially be relayed for many, many calls, right? Should you be able to tinker it and listen to the calls? Oh, no, absolutely not, right? So somebody needs to design a system to make sure that even if there's somebody who's gone through the trouble of decompiling Skype, which by the way is actually quite a feat. The people who made Skype were actually hackers, and they did a really good job of like making Skype hard to disassemble. Even if you get through all that stuff, you need to make sure that your keys are strong enough, that your mechanisms are implemented correctly, so that even if you know how everything works, it can't be reversed, or the security can't be reduced. Does that make sense? Cool. Number 2, authenticate while also avoiding bypass from authentication. What could that possibly be? You mean you saw some examples of that in your web products, right? So, what are you doing when you're trying to authenticate? Right? Well, authentication means that I think you're you, but I want to be sure. So how do we clarify that this person who claims to be, I don't know, Vaidi, is actually Vaidi? Coming in to change one person's grade after the fact. Should better authenticate that person. How would we know that Vaidi is Vaidi? What tools do we have at our disposal?
I mean, I guess, yeah, the authentication from before, so like, you send them a number and say, hash this with your password, I'll hash it with my knowledge of your password, and then make sure that the hashes match up.
But that means that that person has a password, right? That you know and they know, right? So it's something that only they should know.
Yeah.
And they shouldn't be leaking their password, like, that can't be, right? So that's one way, right? It's something like that, in trying to do that exchange without revealing during what's happening, right? So it's usually something like things that you know, but it can be more than that. You can authenticate in several different ways. They're called multi-factor authentication. It could be something that you are. This is like the bathroom in that place that you're working, right? That retina scanner. I don't know why it's there, but it's just there because it's cool or whatever. Actually, in Iceland, there's a gym that for the past 15 years has required a retina scanner to get in. And everybody thinks it's cool. So like they have like the retina of all the whole population effectively. Just because like people don't have like cards and stuff, they just go there and like I'm entering a gym. This is ridiculous. Anyway, that's and then it can be something that you have, right? It could be that smartphone, which hopefully you have, and other people. It could be that two-factor token, RSA token ID when you're working for the government, some other places, right? And sometimes you want to combine these things. It could be something that you know as well as something that you have, or you could need a retina stuff and a password or a voice break, right? Multiple factors will reduce the chance that you're authenticating somebody who is not really who this. And you have to make sure that these things are unique to the user, right? What if you're doing kind of like biometrics and I don't know, identical twins, or passwords are such that they can be 4 letters long, right? Or when you're authenticating a person, be like, oh, you forgot your password. Let me ask you some trivial questions. What is your mother's maiden name? Right? You probably looked that up. There are sub-communities on the internet that will try for celebrities figure out all these questions. They're like, oh, this is the picture of that person's car. And they have a security question, which is, what's the make of your first car? What kind of a car is it? That's how there was this celebrity leak of naked pictures, that this was the main mechanism by which it was enabled. It was that Apple had these security questions that were really weak and enabled you to get access to backups from people's phones and so forth. So in other words, knowing this information is equivalent to being able to authenticate as that user. So this is the weakest thing to get in. Make sure you don't have that. In fact, you should always rethink how you do password recovery. Other people may share your IP address. So if it's like, oh, they must be the same person, they're from the same IP. Well, then everybody at Emory is the same person, right? Because we're all going to have that same firewall, right? Or they can spoof your Mac on the wireless router, right? Or if it's so that, like, yeah, you can authenticate with the password, and once you have authenticated, you go to that obscure URL that nobody knows. But what if somebody finds that out by looking at logs, or by doing a JavaScript authentication system? Then they have become you. So, usually, and this is something we talked about with respect to cookies, when you authenticate, you're giving something so that you don't have to authenticate on every single request. Usually when you have a stateless protocol, you're given a token. And a token has to have an expiration attached to it, or it should have an expiration attached to it. Like I give you sometimes called capability or credential or ticket. And it's important that you're able to make these at least as hard to generate as the information that they're required to authenticate to begin with. Like if the authentication token is just the number 1, and then 2, and so forth. Right? That has happened. If you have sequential numbers, just like, oh yeah, you're the 5th authenticated user today. Congratulations. And you use that number to walk in. Or if it's really bad pseudo-random number generation, or it's the same seed, or the seed is the time when you authenticate it, or whatever. Right? Why do we need to limit the lifetime of these tokens? Can somebody think of an attack where, if these are not limitless? Yeah, exactly. Exactly, so you have these tokens lying around, somebody walks up to your laptop and now they have all your credentials. Or somebody sees the cookies in a log file, right? Then they become your user. Or maybe they've been authenticated, but they've been since they're kicked out of the organization. Well, better be the case that you can somehow revoke these. Also, when the user's suddenly like, I found yourself in a bank, and then they're like, oh yeah, I need to transfer money. Yes, it's to my good friend in Uzbekistan, right? You should consider like, did that person just log on using a token that I issued a while back? Maybe I should re-authenticate just in case, or ask for more information when there's critical operations like that. And in fact, that's exactly what banks do. They consider how you logged on at every given point in time, and then they may ask you more questions just to kind of raise the kind of bar when you're doing something that's considered critical. Okay? And then also, when you're designing the systems, it's really easy to overdo them. Imagine, and you've seen this, like Emory is this classic example of this, right? It's like, if you train your users to constantly be typing their passwords whenever they're prompted, they will, right? They're not going to invest the mental energy to be like, is this legitimate or not? Well, I have to do this 5 times an hour, right? Or I have to change my password every month. Yeah, you're going to have the weakest passwords in the world if you do that, right? Nobody's going to remember them, so then they're going to rely entirely on your backup authentication protocol. Therefore, if you get reminders that's like, oh, you reset your password on this, like that's an email you get every day because you never remember your password, and they're going to be saved down in the browsers. This is terrible. You need to take into account that people are going to respond to the incentives they're given. If you give them just complete inconvenience, then yeah, they're going to give you lax security in the stage. When you're designing your system, you want it to be, well, correct, but you'd like it to be also just a single authentication system, and as minimal as it can be. Why? Because then you kind of have this narrow waist business going on, this choke point. This thing where you can't get into your system unless you pass through this authentication checkpoint, if you like. Right? So whenever there's a request to your system, it first goes to the authentication mechanism to see, like, are you still valid? And then moves on to wherever it needs to go. This also should re-authenticate to automatically when things expire and so forth. You don't want to have logic about authentication all over the place in your code, because you're going to do it wrong one of the times. And it's, in this particular case, it's simplest to use something that's tried and true. Kerberos, open authentication, variety of different things. Don't try to invent your own. How many people are still asleep? Or still with me?
Yep.
Okay, few left. Okay, great. Well, let me try harder. These are important things. Like, I mean, and this is the essence of computer security. Is that you're going to have to do some boring stuff to make your system safer, because when you don't do that, you'll have a really, really sad phone call to a company like mine. I don't know what's done. It's terrible, don't do it. It's good for business, but it's not your business. So, imagine that you're building Triton, right, or Linux, like a shared server. And you're doing it for the first time, and you're usually doing it with like a small group of people. Then usually it means that like, oh yeah, there's just this big shared password, and then you have full access. It's kind of like web encryption, if you think about your wireless setup. Now that's great, until something happens, right? When that first person is like, oh, our shared chat channel has been compromised, and people are doing stuff, or our shared server, like, oh, I don't know who did what, because everybody just had full access to everything. So, yeah, you kind of end up like Lord of the Flies, like everything just catastrophically falls down a slippery slope to chaos. So, what you do after authentication is the third A, right? You try to authorize people to do stuff. So, suppose that bad things happen. For instance, somebody was authenticated and yeah, the laptop got stolen. And then another person went in and tried to transfer all the money out of the company. Right? Probably not good. Maybe that person shouldn't have full access to transferring all the money out of the company to begin with. They should maybe be given explicit permissions or privileges to do that when they need it, which is probably not. Right? So, what if the person left the company? Should they still be able to withdraw cash from it? You want to be able to somehow authorize people to do different things and limit how much they can do so that your damage is limited. That's why you as users of Emory, you cannot install new drivers into the computers that are owned by the network. You can't look at patient files without specific permissions and so forth. There's a lot of stuff you can't do. On Triton, you can't have root privileges. I know you guys try, and I know I can taunt you with it, but you can't have it because you get everybody else's grades and so forth. Okay? When you're building your own systems and you're thinking about authorization, you should also take into account that, like, hey, wait a minute, let's look at the context. This person just logged on at 3 a.m. It's a person that goes to sleep at 9 p.m. every day, like clockwork. And it's from, it's a different country for 5 years. It's from Norway, where this person has never been. Maybe I should limit the privileges I'm giving them and then have them re-authenticate for more, or ask for more, or file something, right? Make sure that you take the context into account when you're giving privileges, right? For instance, ATMs, when they were designed, there's a daily limit of how much you can withdraw from the account. Precisely because, what if somebody stole somebody's credit card and had the PIN number? Well, it can still only take up to that maximum limit. So give each user profile or process the minimal privileges it needs to do the job. This is called the principle of least privilege. This is something that's taught in security courses around, and you'll hear this kind of touted around. This was an extremely successful idea that came out of years of experimenting, and this is the principle in Unix. Right? If you have a process in Unix, it really shouldn't be able to eject the CD-ROM if it doesn't have to. And so then it can't, right? Or you have a sandbox where like somebody can connect to the internet on port 80 and that's it. They can't open any other files, they don't see any other files, they can't touch any other processes. That type of isolation prevents a lot of the damage that could happen if you have a weird compromise. Right? So that's called sandboxing. And then there's another principle here of layered defense. You remember the first class when I talked about how there's this perimeter that people have and they spend a lot of effort trying to have that perimeter as safe as possible? I also mentioned that this is one of the easiest things to overcome, right? Because you have employees inside and they do stuff. They open cat videos because they're cute, right? Even if they came from somebody who doesn't spell the name of the CEO properly, right? So it's easy to bypass that first perimeter. And it seems that once you're inside, a lot of companies have no provisions about security. It's just like, oh, it's just a gentleman's club right here. Right? You just like go in and everything just like can open any drawer and collect all this stuff, and it's like, yeah, hey, what's up, right? You would never have that in a physical organization. You always have locked doors like this classroom, right? Layered security means that you try to make it harder and harder to get to the most important stuff that's in your organization. Like you should have special privileges to get to the credit card payment system. It should in fact be firewalled off of the rest of the thing. There should be another layer here about all the databases, and they have special privileges and their own special service, maybe special racks, all their admins. Not everybody has default access to them. Different applications might have different tiers, so they may be segregated apart, so that if you compromise one of them, then you can't move to different applications and so forth. There should be this kind of layers of security within your organization. You should be monitoring what's going on here so you can see what happens later, and you should be periodically checking how good this is. How do you do that? How would you test the security of your organization or of your department?
You could give someone low-level access and then tell them do what you can.
You could do that.
Security purposes.
Yeah, exactly. And that's what a lot of banks and other organizations do. In fact, the ones with probably the greatest security postures are the ones that contract out and say like, hey, here's you now have access to this employee's laptop over here. And you have 2 weeks. Show us how much information you can gather and how much we can detect from that. And then you just play around and you be like, oh, okay, you found a way around all this stuff, or you were able to like get credit cards, that's terrible. Then you learn from that, because you have to be constantly learning. You have to be agile if you want to stay on top of security, because it's an ever-changing landscape. So make sure you have these, make sure you monitor stuff, make sure that you get feedback on how good it is, retrain your employees, make sure everybody's on board with security. We try to do it in a positive, incentivized way. Incentivize people to participate in security, because it is, okay, I'm not there yet. Security is intermediate. Okay. Any questions so far? Do you want a pillow? No? Okay. Segregation of data and control. So, what does this mean? Data and control should be segregated or separated. What do I mean by this?
Well, like in the one I exploited, like the stack, and stack
Uh-huh.
6 people, you had them all intermixed. So you have
Mm.
your actual data and then your commands, and you could just, skip over and like
Weave
run
between
things
them.
and create your own thing.
Yeah, C-stack, it mixes the old register values that the computer needs to maintain its control flow with your data. You buffer and stuff, right? So yeah, you get control flow level hijacks and all sorts of stuff like that. And then you also have similar problems with some of the higher level languages. And we've now talked a little bit about this. Any examples? Where we mix control and data. Well, how about this, right? I send you a string, and whoever is looking at the string is thinking about it as being HTML, or parses it as HTML. Then everything inside these angle brackets over here is going to be interpreted as control, something that controls your DOM and your browser. And everything else is just data, right? You can put in scripts and all sorts of things. Yes, you guys are doing this all last week, right? Well, SQL, right? Where you have like a query that's all kind of, actually, I flipped the colors. This is all control and this is all data. And if I put in a quote here, I've broken the boundary between data and control, right? Or format strings, where like %sign means something special to the format string engine, right? The printf or whatever. Here's another one, and we haven't talked about this a lot, but there's this very high temptation when you're a JavaScript programmer or you're a Python programmer and you're trying to parse stuff. Parsing is really boring and it's hard to do right, and so you try to take shortcuts. And sometimes the shortcuts you take is just like, I'll just let the JavaScript runtime evaluate this for me. Yes, you made a deal with the devil, right? So you know you're being lazy. You do something like this. You're like, my virus, like, this is varnammer, this is PHP. I'm going to get this argument here, x, and I'm just going to like set it. So I'm just going to do an eval. This equals that. So it's like Python code, and I just put it into it. And stay away from pickle and so forth in Python. Pickle all these structures and so forth. If a user can tinker with it, or you're accepting a pickle that's stored at another place or something like that, yeah, it's going to have bad stuff in it. Right? You guys get why this is bad. What would you put inside X? Any PSP right? Can you make it into a string that's like different variable? It gets really, it's a really slippery slope right there. Okay? Whenever you're faced with a dilemma of like, oh, okay, am I looking at this as a string, or is it a string that could possibly have any type of control information with it? Then you should probably rethink what API you're using. So stay away from the APIs where like it accepts a string and then like it could be echoed back to the user, like the reflection attacks and cross-site scripting and so forth. So try to have something that uses structured types. For instance, like it accepts a DOM tree, and the tree itself is very well specified of what is in it and what's not, and you can filter out things you don't want or come from the user. Or it's a string that's not being interpreted by anyone. Or it's already URL encoded, and you know that's not going to cause any problems and so forth. Just know your APIs. So here, just to wake you guys up, is a comic. Just here to wake up. Ding, 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 ding. Yeah. It's one way to harness those questions, right? All right. There we go. Number 5. That's a really sad wave. It's just me. Oh, I knew, yeah! It's like a really transient wave. It's mostly like kind of destructive interference right here. Yeah. All right. Validating data. Okay. So you get data from users, right? And users are the ones that are malicious. So you need to make sure you validate that data properly. How do you do that? There is this notion of trying to have kind of a central validator, something that if you go through and just make sure that your data is correct. It's hard to get that right, but you need to make sure that you have something like that. And so one of the things that you can do is that whenever you are faced with any type of, suppose you're asking for a timestamp from a user, right? Now there's a gazillion ways you can write a timestamp. So in your program, you don't want to be in the case where you're just carrying a string around, which is whatever the user wrote. You would like to very early on in your central validation mechanism to convert it into a canonical timestamp, something that like actually makes sense. And then just use that representation for the rest of your program. Because otherwise, you're risking that every single time you're parsing a timestamp, something goes wrong. Or somebody's using a different library for parsing it, and the differences between them. So if you do this, you're minimizing the way in which the attacker can possibly affect your control. Path names, for instance. You get a path name from the user. Remember the ... magic that you guys were pulling? Yes, right? The first time you see a path name, you should be looking at what's the real path of this thing here. And that then becomes your path variable that you move around instead of the argument. Because it's going to go wrong on it. Use preconditions. How many people know what preconditions are for code? Did you guys go through that at some point? I see. All right. Anybody take functional programming? Do we teach functional programming? There's a lot of silence on the line. Still there? Hello? So, functional programming. Okay, never mind that. When you're writing code, sometimes you're writing code that's kind of complex and it's hard to get right. And in fact, you spend 90% of your time working on 10% of your code. And that's that complicated piece of code. Usually it's algorithms or stuff that is just like, this is really hairy, like parsing, and it's really annoying and it makes you feel bad. And then you have to do your like showering and like, oh, I know what the bug is, it's just stupid, blah, 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 and you hate yourself, right? So, In order to avoid some of that, you could use preconditions. Yeah. What are preconditions? It is what you know was true, or needs to be true for your method that you just wrote to successfully execute. So you have your method that accepts some parameters and you do some stuff, but you've made implicit assumptions about what was true for your parameters. For instance, that there's a canonical style date that went inside them, or that it was a URL encoded string, or the date that came in is not in the future. Like you can make these, that f is not null, or has been opened, or cleaned, while it exists. Those are all preconditions about what you assumed the state was of the world before you entered execution. If you write these things down, then it's easy for it to come later and be like, oh, there's a bug. Oh, okay, wait a minute. When I was calling this method over here, I didn't actually fulfill the preconditions. And then there's this called postconditions, which is what is now true after you've executed your method. You can generalize this thing and go even further and say, I'm about to do a loop, and it's a weird loop. It's the partition thing from quicksort, and it's really complicated. If I put down a precondition of what's true every single iteration of the loop, it's much easier for me to write it correctly. Somebody did a study of binary search and found that I think like between 70 and 90% of programmers, if you just ask them right now at a gunpoint or whatever you want, like sure, gunpoint, to write binary search, if they actually write something, it's going to be wrong. 70 or 90% of the time. It's going to be corner cases that weren't caught. Whereas if they were forced to write first like a precondition of like, is it true that the interval you're searching includes both endpoints or just one of the endpoints? To write these things down, you've clarified your thought in coming up with your code, and therefore your code is more likely to be correct. So those are good things to keep around for algorithms. They're especially good for security as well. You're making assumptions that like, hey, I have access to write to the file descriptor, that's my first argument. You're making this assumption. But then later when you call that method, you may have forgotten about that assumption. You didn't check it. That's when bugs come up. Okay? Preconditions are your true. And you can even then add assertions and stuff to make sure that they're true. And those don't have to be in your production code if they slow things down. They can be while you're testing. Right. And then, of course, if your control flow, if something is dependent on data that has not been validated, well, that's when, bad things happen. That is a car that's almost a garbage bucket. How it happened, I do not know. But I'm sure it's not part of the freedom. So, that's order for that. What's the first rule of crypto club? Don't roll your own crypto, right? Do not roll your own crypto. You will fail. Well, why will you fail? Because there are all these subtle things when you're writing crypto. You're like, oh, this is great, yeah. And then like after rigorous mathematical analysis, you realize like, oh, oops, I didn't actually run the message properly. Or, oh, when I mix these things together, they cancel out. So it's all clear, right? Extremely easy to make crypto code so complex you can't reason about it, but still completely unsecret, right? So when people were developing these crypto systems, and I'll upload a lecture about what they were doing in the Second World War. That's Wednesday's lecture for CS453, which will be uploaded. What they were doing is they were trying to come up with these crypto systems. They were assuming that the enemy could not possibly come and get the actual blueprints of what the system should do. But of course, the enemy was able to get that, right? People would bribe, they would have spies that got them, they would bribe things, they would actually, sometimes they would, in the Second World War, somebody actually went into a submarine and pried the code book out of the hands of a dead soldier, stood and ran out before he was drowned. Like, it was like crazy stunts that people pulled off to try to get access to what the keys were and what the crypto systems looked like. And we started making good progress on crypto systems when this principle started to be applied, Kirchhoff's principle, which is that assume that your enemy knows everything about your system except your keys, so that your security of your entire thing is dependent only on those keys and how well you're protecting those, right? Everything else is in the clear. And that's a really useful way to think about it. Now, if you're need to have cryptography, which is pretty common today. Try to involve an expert, somebody who at least understands the libraries you're using, openness and so on and so forth, can glue them in with you. Like, you can try to learn this stuff up, but it is good to get at least hand-holding from somebody who knows this stuff. Understand key management. Who's responsible for issuing keys? Can you revoke keys later? Suppose you get hacked and you need to change your key. Can you in your code? How do you distribute keys? For instance, if you were the developer of DVD, you're like, oh no, I hard-coded the key into everything, and now that key is forever out there, and never can decrypt any DVD in the world. Oh no, right? Yeah, if you had better key management, you could have avoided that. So, this is something that's important here. Okay, remember your users. Remember who you work for, really, right? This is a point I was raising earlier. Security is an inconvenience, right? You don't really get anything from security other than security itself, and it takes something away. It makes things less efficient when you're doing checks. You have to ask your users to do stuff that they hate doing, like enter the passwords and like, right, whatever it is that you do, or pull up their smartphones. And yeah, it's all really inconvenient. And so you want to somehow make sure that you factor in user experience and the users themselves when you're reasoning about your system. Sometimes you'll, for instance, when people are coming up with CAPTCHA, remember CAPTCHA, like these characters that are all weird and so forth? Well, what about blind users, right? And then, of course, like Silicon was like, oh, right? I mean, there's all sorts of different things you have to factor in when you're making software. So then they came out with audio capture, which is, I think, similarly good now. Where you have to think about that you have users that have very different security profiles from yourself, right? You have to worry about how people are actually going to use your system, because they may evolve in ways that you didn't anticipate. You make your system, and then people just start, I mean, if it's really hard to, like, you have to have 40-letter passwords, how is it going to be used? Yeah, people are going to be circulating this like yellow sticky notes with long passwords, right? That's how it will be used. So you want to be able to have a system where you have security controls, some means of knowing that, like, hey, if you do this and that, you have better security. Something that expresses the intent of the security thing I would add. Like if you add more security to your Chrome browser, to Internet Explorer, to email or something, you would be able to express it, but you don't want it to be completely excessive. Security should be kind of understandable by the people who are actually using your system. If it's just esoteric gibberish, you're just going to touch the defaults, nobody's going to do anything. It's going to backfire if you're going to try to have excessively authoritarian security schemes. And embrace the fact that some of your users are actually going to find stuff you didn't anticipate. They're going to be like, oh, if I change this ID over here, I can read somebody else's email. Huh, how funny. Right? They're going to, they may be able to find files from other users. Maybe you have a temp folder that's shared, and all of a sudden you start tinkering with the temp folder. Right? This temp folder on track them. You guys tinkering with its other stuff? Right? Some users may not care about security. Imagine that. The people may not care about the stuff that you're learning about. Most people don't. Right? So you need to embrace that reality. If you would embrace that reality, how should you design your system? You need to make sure that by default, it's as safe as it can be, right? This is reality here, right? Here's a gate. It's a security gate. This is locked. Mm-hmm. You seen this on campus?
Mm-hmm.
Wow, yeah. Yeah, somebody's missing a front wheel. It's Christian perspective. Yeah, that's so sad. Yeah, you're like unicycling here. half a bike here. Yeah, great. So, yeah, motivate and incentivize your users to do well. So if you want people to engage in your security schemes, like your two-factor and so forth, make it fun, or make them in the know of what they're doing, why they're doing it, and just try to make sure that you're being considerate to their needs as well. If you put in a draconian password policy, people are going to have absolutely, they're going to spite you, and then they're also going to put in the minimum required password just because, right? Do you really need to give your users so many choices about security stuff? Do they need to choose all this different? Can you actually choose most of it for them? Every choice that a user needs to make is a headache. They stop and to think about it, and they can get overwhelmed really easily. Make the default choices good, right? And when I say good, I mean that it shouldn't be the case that when something fails in your program, or when your things are just like you set up your Chromecast or you set up your wireless network, it shouldn't be open by default. What are you talking about? There's going to be a really significant portion of people who are going to just leave it at the default configuration. So the default configuration needs to be as good as you can make it, right? And then also factor in that some of the people may be insiders, right? They may be malicious people who have some of those privileges. How can you minimize what they can do or mitigate damage, right? Can you assess how much damage they could possibly do? Or is it limitless? So always consider your users and any other stakeholders when you're designing and evaluating your system. Minimize surprise. And then also make sure that your defaults are as secure as you can make them. And when you fail, don't fail, be like, oh, I failed, here's like an open administrator access, you can fix it, right? Fail securely. This actually is a really common mistake. Like things just, when there's something that happens, it's just like, oh, okay, I'm gonna return 0 because I don't know what to do. And then there's some process waiting for it to be like, oh, what's the user ID of this person that's logging on? Oh, it's 0. Which is root, right? This happens. 0. Yeah, that also right. This is the actual principle. Don't trust people. This is just reiterating an earlier point. Now, here's another one. External compromises. Is any fun in? Okay. You, especially when you're writing anything related to the web, but in fact, most software development, you're going to be using stuff that somebody else wrote. There's going to be other people at the company who've been writing it, or you're going to be downloading third-party libraries, or open source stuff, or simply like custom stuff. Which means that every time you do so, you're inheriting all of the problems attached to that component. Even if you try to ignore it, hope that it goes away, it's still there. If you use zlib to compress stuff, that means that you need to be able to update it when there's a vulnerability. Even if it hasn't happened in a long time, when it happens, you need to be able to have a remedy on it. You inherit the vulnerabilities, the maintenance responsibility, as well as the threat model. What's the threat model, right? Threat model looks kind of like this, right? You take your whole system, you try to assess where are the ways you can get in, and then you look at the risk attached to it. Risk here being, how easy is it to exploit? There's a bug in this particular part here. How easy to discover? When can it actually arise? If it is exploitable and it's actually possible because of the circumstances of how things are sent, then suppose somebody did it, how much damage did they do? So risk is really damage times the probability that something may happen. When you look at this, you get a number, and that's your risk number. So you can take your entire system, you can try to assess its risk through this type of analysis. It's really fluffy, but there's a bit of science to it. And when you are a C-level executive, this is paramount to be able to do. You need to be able to see like, okay, we have all these things here. I could invest this many resources into trying to make this part better because the risk is too high, right? If some, like, it's unlikely something happens, but if it happens, it will kill the organization. Therefore, I should try to mitigate that. Right? So make sure that you have this threat model always in mind when you're making your software. And that includes the threat models of all the things that you inherited. So for each component, you need to consider, like, how does it change your threat model? How does it change your attack surface? What are the ways in which things can get in? Is it like, are you exposing APIs to the outside world? Are you exposing protocols or websites that people could get in through? Can you trust the source of this component? Like, suppose that you have a JavaScript library that you just embedded into it. What if somebody hacked their GitHub that had that stupid JavaScript library that you rely on? Doesn't mean that they hack all your users? Yeah, it seems like that's pretty common today. Is there a way for you in which you can ensure that you have some key management about what components you're doing, or that it's been signed by somebody whom you can trust? If it has a whole bunch of features, that's opportunity for bugs. Can you disable those unused features? I was just meeting with the Office of Naval Research, and they're like, this is like the key thing that we want to focus on. We want to give a lot of money for means in which we can disable features we're not using, because this is the biggest part of our attack surface. Okay. How is stuff being maintained? Is somebody maintaining GitHub, or that other library you stole, or that daemon that you're running that just happened to be there? Is there documentation about its security features? Do you know something about its threat landscape or how it's supposed to be used? Design your stuff for flexibility, right? If your component suddenly stops to meet your security goals, maybe your security goals changed, or maybe theirs changed, or something else came up, you need to be able to discard it. And you need to be able to not have to like pry it out like some sort of organ that's embedded inside this piece that you created, right? You need to be able to take it out and stick something else back in, because it's all so modular and flexible, the software you created. Okay? Right? And then when you're setting these things up, document everything, so you will forget. Right? And when you can, isolate stuff. If there's anything external running, put it in a sandbox. That sandbox means that it has a reduced interface to your kernel and other parts of the world. Put it inside a rooted container, a Docker container maybe, that doesn't see any other files or any other processes, right? Drop the privileges to the least privilege that it needs to do its job, right? Do not trust it. This is the trust no one aspect. And then finally, think about the future. Think about the children. When you're making secure software, when you're trying to make your software so that it's resilient to new attacks, you need to make sure that you're able to accommodate change, right? Your threats are going to change. There's going to be new types of threats. Like, people that know about cross-site scripting, they're all like, oh, buffer over, then all of a sudden there's this new kind of platform of web vulnerabilities that wasn't on people's radar. You need to be able to adapt to those things, right? Mobile. So you need to be flexible on it. If you write your security software, do you have any mechanism to update software when it's blocked? Or do you need to like scramble and call every customer? Do you know who your customers are, right? What are you going to do? Do you have a policy for this? Just have a policy for this. Do you need to change your security properties at some point? Can you? If you do, what needs to change? Where does it need to change? Do you have a means of doing this? Can you possibly turn off things if you need to? For instance, if you realize that you're Adobe and you made this Adobe Reader and it has all these features that are full of bugs, can you, for instance, disable the useless JavaScript compiler you have in there? It'll be probably pretty prudent. You can tell people to disable while a bug is being, or like while a patch is being used. Can users change their passwords? Can they do that securely? Or any other information that they might need? And yeah, this is an old point here, but password recovery. If you need to revoke the certificate, suppose there's an SSL certificate in there to make sure that it connects, or you're using VPN internally in your product, can you revoke the certificates that were embedded in there and put in new ones? How do you do that? Is that process as safe as the process that you're trying to protect? Or is it just like, oh no, yeah, anybody can change certificate? Which of course invalidates the whole thing. That's the same thing, like in your Amazon deployment so forth. Just because something has been fine so far doesn't mean it'll stay fine. Bugs come, bugs go, and so forth. So that's a whole bunch of stuff. Yeah, I was going to try to set out an extra assignment for an extra 5% if you get one, which is about playing poker. Yeah. So you will, I'm gonna set this up later today, and I'll send out details on Piazza. But the idea is that you start off and you have $10,000 on a server, service hosted elsewhere. You get the source code for that server, and also source code of a kind of a C client, architect. Then you can play poker, you can connect, do all these things. And you're supposed to win $10 million somehow. And if you run below your $10,000, you're gonna have to ask me for a refill once. Get out of jail for a year. So how are you gonna attack this? Hint, it's not a buffer overflow or anything like that. It has something to do with randomness. Sound fun? Cool. Okay, so I'll post more details about this later. It's an extra 5% country grade if you want to pad things up a little bit. Other than that, any questions? No? Then I say happy Thanksgiving. If you want to toddle with me up to my office to look at your exams, feel free to. Otherwise, see you next week.